Hello class, and welcome to lesson 5.1, the first lesson in unit 5 that we're dealing with, and unit 5 is on probability distribution. So we're taking the extension from last unit, and instead of just looking at the probability of, for example, rolling a 4, we'll take a look at the probability of rolling a 1, a 2, a 3, a 4, a 5, and a 6. So we'll take a look at all the possible ways and the probabilities of solving any answer. So instead of saying, what's the probability of winning the grand prize for lottery, we take a look at the probability of not winning versus the grand prize, maybe the second place prize or the third place prize. So we take a look at all probabilities of all possible situations. So that's where we're heading this unit. Believe it or not, we only have 2 more units left in the course, Unit 5 and Unit 6. And this is why, in the warm-ups, we need to make sure we take a look at the difference between discrete data, which focuses on this unit, which is Unit 5, and then we're going to stretch on to Unit 6 for what's called continuous data. And that is going to be the end of our course. Holy moly. All right, so let's just remember, what is the difference between discrete and continuous data? Okay, so remember, discrete is anything that's countable. Okay, so you can count them, like number of books. Okay. Okay, so if you count them, you can either have 1 book, 2 books, 3 books, 4 books. You can't have 3.4 books. Okay, versus, let's take a look at the opposite, which is continuous data. Okay, and continuous data is measurable, which means it's something that you can have a decimal with. So it's measurable sets, we call it. Oop, I don't think that E's supposed to be in there. Okay. And so remember, with this, you can have decimals and fractions. So for example, if I measure the height of a plant, it could be 3.4 centimeters or 4.8 meters or height of something. So anything that allows you to have a fraction or a decimal. Okay? All right. So let's just do a quick refresher. I think this is from Unit 1 when we did it. Maybe one of your first lessons. Classify each of the following as discrete or continuous. So the number of goals scored in a soccer game. Remember, it's the number of something, means it has to be discrete. Okay. B, the length of time spent studying for a test. That's continuous. Okay, and again, the number of tires a company sells in a day, that's discrete. All right, let's get into doing some probability distributions. Here we go. So today's expectation is to identify, we already did continuous and discrete random variables, and then we're going to construct a probability distribution for discrete data. So that's what we're going to focus on today. So we're going to do some new looking graphs today. All right. One thing that's important for us to note before we get started is I'd like you to box this if you can. Okay. We're going to talk about what's called the random variable. So it's the set of all answers to a question. Okay. There is a single value for each outcome of the experiment. Okay. So we're going to use capital letters for the set of answers. Okay. So that X, for example, could be the outcome of rolling a die. So that could be the capital X. The lowercase would be the individual values. So the lowercase x would be when you roll a 1, or you roll a 2, a 3, a 4, etc. So that's all the possible outcomes, and this is kind of like your event. Okay? Okay? All right. So, we're going to take a look at your textbook on page 369, Investigate an Inquiry and Perform 10 Trials. So basically, you're given some cards and you need to pull out an A. And since we're not doing this in class, I'll pretend that we did this trial 10 times. Okay? And pretend, this is going to match the answers on the website, pretend group 2 got 4, pretend group 3, the third group got 1, pretend the fourth group got 1, and the fifth group got 4, which means that the first group didn't get any A's. Okay, so we take a look at the frequency, you total them up, just like a tally. But now what's different is what we call experimental or relative frequency. Okay, well, we want to do it on a total. So the relative frequency is kind of like your probability. So 0 out of 10, because they got 0 out of 10, which means their probability of getting it is 0. Group 2, or the second group, got 4 out of 10, which equals 0.4. Group 3 got 1 out of 10. Sorry, I'm just fixing that. 1 out of 10, which equals 0.1. Same with the fourth group. And then the fifth group got 4 out of 10. 0.4. Okay? So now let's take a look at how does this compare to theoretical probability, because this is experimental, right? This is the experimental probability. Now, if we did the theoretical probability, so the probability of getting an A, okay, or of group A going first, okay, is 1 over 5, because there's 5 total groups, okay? All right, that makes more sense if we were actually in class and we could do that experiment together, so I hope that's okay for you. Please see me if that has you confused. Okay, in the last unit we were interested in a particular outcome. For example, what's the probability of winning the grand prize? Okay, so in this example, what's the probability that group A presents first? Okay, all right, in this unit we were interested in all possible outcomes. Okay, so we're doing what's called a probability distribution, which shows all possible outcomes. Okay, so here's probability distribution, guys. Please make sure you got this boxed and that you've got it highlighted. Okay, a probability distribution is all of the probabilities for the all possible outcomes of an experiment. It's usually displayed in a table or a graph. And remember that the sum of all the probabilities equals 1. Okay? That tells you it's a check to make sure you've done your numbers correctly. All right. So, in this investigation, A, which is the in this investigation, the random variable is the capital X, meaning the group A presentation order. Okay, and that enlists all the possible ways that could happen. Okay, now we're going to show you the probability distribution, which is all possible outcomes but related to the probability. Okay, so in the last couple units we did a tree diagram that showed you all possibilities. Now we're doing the probabilities associated to all possible outcomes. All right, so I'm just going to copy the answers from your relative frequency from the first chart, the table on the first page that we did this lesson on. Okay, so, and remember guys that this is the experimental probability. Okay, if we were in class, we'd be getting people to pick it out, okay? So, that's one way to display it, and if you totaled everything up, totaled this all up, okay, it would be 1.0, okay, or 100%, okay? When we do it in graph form, we put our probability on the y-axis, so probability related to each outcome, okay? And then on the bottom, we put each possible outcome, which is your lowercase x, okay? All right, so what we want to do first is take a look at our probability values in our chart, and we want to say, hey, our lowest is 0, okay? And then our highest is 0.4. So looking at our chart, I think we could go up every 4 by 0.1. So 1, 2, 3, 4, 0.1. 1, 2, 3, 4, 0.2. 1, 2, 3, 4, 0.3. 1, 2, 3, 4, 0.4. Okay, just to spread it out, because you want to make sure you can visually see it. Now on the X, let's put our groups. So we can just go by threes. 1, 2, 3, that's group 1. 2, 3, group 2. Group 3. All right. Now this is what's different, folks. When we go to match this up, Okay, so if we take a look at group 1, it gets 0. So put a little dot, and that's it. Okay, now this is what's going to be interesting and new about probability distribution graphs. Okay, at 2, you're at 0.4. Okay, but because you're either group 1 or group 2, you draw a solid line down. This is why, because it's discrete data. Okay, we'll learn something different when we have continuous data. Okay, so for 3, it's 0.1. Draw, it's kind of like a tadpole if you want to think about it. Okay, or a flagpole, some people have called it as. All right, so the 5th group is at 0.4. Okay, don't forget what's the last thing that we have to do to our graph? Put a title on it, so it's going to be presentation order. For group A. All right. All right, so the above distribution was based on what we call experimental probabilities, okay? Usually we will base our distribution on theoretical probability because theoretical, again, is based on laws and formulas, okay? Let's just go up here and put on, oh, actually we'll do it in a second. I don't want to jump ahead of myself, okay? So let's take a look, folks, at figuring this out. In the investigation, what's the probability that they will go first? Well, hey, if there's 5 different orders, 1, 2, 3, 4, 5, and the probability of them going first means they're at the top, there we go. So probability of them being first equals the number of ways where x equals 1 over the number of ways in our sample. Okay, well, if they're going first, then it's going to be 4 times 3 times 2 times 1, which is 4 factorial, over the number in our sample, which is 5 factorial. Okay, and this equals 1 over 5. So you have a 1 in 5th chance of going first. Okay, so that is a probability based on going first. Okay. Okay. Which equals 0.2. Okay, what's probability of going second? Well, if I draw the same thing out, 1, 2, 3, 4, 5, I'm in red now, and I put a group A in second. Well, again, there's still going to be 4, 3, 2, 1. So it's going to be 4 factorial over 5 factorial. It's going to be the same. Okay, so in fact, in this case, the relative frequency is going to be the same for each outcome because it's equally likely. Again, an experiment doesn't show that always, even though it should have. Okay. Now it says place this on a different color in your graph. So let's do that. For theoretical probability, in this case, it was exactly the same. So you'll find that if they have uniform distribution, which we're going to get into. So I'm looking for 0.2. And I'm going to put a dot on each one of these. And then just draw my tail, either flagpole or tadpole, whatever you want to think. Okay? All right. So let's take a look at what situations give us uniform distribution. Okay, and again, uniform probability distribution is when all outcomes are equally likely. Okay, so again, flipping a coin is equally likely. Okay, drawing a card, not just a card. Okay, rolling a die. Okay, as well as a theoretical problem like what's on the last page. Okay, that's pretty specific, so I'm not going to write that one down. But those are the 3 main ones you're going to see. All right. Number 1, define the random variable for each of the following situations. So a committee will be selected, and it's important that there is a fair representation by gender. Okay. So we can take a look at doing the random variable being the number of males or the number of females, okay? So capital X, you could say, is the number of males, because it's by gender. Or you could have also introduced your problem as the number of females. Okay? And again, remember that this is discrete because it's number of people, right? You can't have 10.4 people, right? All right, let's take a look at the next one. B, a machine produces bolts and the manufacturer is interested in the number of bolts that are longer than 60 millimeters. Okay, so our random variable x is the number of bolts that are greater than 60 millimeters. Okay, now folks, it's the number of bolts, right? So because it's the number we're interested in, not the length, this is also discrete. Okay, now let's take a look at this. A machine produces bolts and the manufacturer is interested in the width of the bolt. Can a width be a decimal or a fraction? You betcha. So this is an example of a continuous situation or continuous data. Okay, and our random variable is going to be the width of a bolt. Awesome. Okay, let's try another example here. Okay, and this is with cards. Okay, so a single card is drawn from a deck of 52. Face cards are worth 10, aces are worth 15, and the other cards are worth their face value. Determine the probability distribution for the value of the card drawn. Okay, so remember, value of the card drawn means that that's going to be our random variable. So our random variable is the value of the card. Okay. Now, the lowercase x, which is all possible cards. So what possible cards could we do? Let's start with 2, because we'll deal with ace later. So 2, 3, 4. I'm going to move this up a bit so I can see how long I got. Oh, good. I got some room. 5, 6, 7, 8, 9, 10. And then what happens, folks? Okay, 10 deals with all the face cards, right? That's the number of points you could have. Okay. And then the ace is worth how many points? 15. Okay, so I'm just going to put down here that this is my ace. Okay, and 10 represents 10, jack, queen, and king. So there's lots in there. Okay. All right. Now, what's the probability of getting each? Okay. So, probability of getting 2s. How many 2s are there? There are 4 2s. Out of a deck of 52, that simplifies to 1 out of 13 in each suit. Okay, same with number 3, there's 4, so it's going to be 113 here. Okay, 113 here, 113, because there's 4 of each of these, so it's the same thing as we go along until we get to this number 10. Okay, so number 10, he's a tricky one. Okay, because there's a 10, a jack, a queen, a king. So there's 4 in each suit. So that's going to be 16 over 52, which simplifies to 4 over 13, because there's a 10, jack, queen, and king. Okay? If you're not sure, I'll write that out. 10, jack, queen, and king of each suit. All right? And then don't forget, for the 15 points, it's ace. So the ace is 4 over 52, which equals 1 over 13, and that's your ace. He's got more points. All right, so folks, here's a case where our fractions are pretty common. You notice that they're all in 13ths, so then we can just do our graph in 13ths. Okay, so our title is going to be value of card game, or of card drawn. Okay. Our probability related to whatever card we pick is going to be here, and our number of cards is going to be here. So we will start and go leave a space for 1 because there's no card that gives you a value of 1. Okay, so we got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? All right. And so what's our maximum fraction we have here, guys? We have 4/13, so we can really spread this out. So 1, 2, 3, 4, 1 over 13, 1, 2, 3, 4, 2 over 13, 1, 2, 3, 4, 3 over 13, 1, 2, 3, 4, 4 over 13. Okay? All right. So let's plot this in. Okay? For most of them, it's going to be at 113. Which is 2, 3, 4, 5, 6, 7, 8, 9, and then 15. Of course, I'm using a straight ruler. Everybody knows that, right? Straight edge. Okay, and then number 10 has 4 over 13. So again, folks, your relative frequency diagram is usually as decimals, but in this case, you could use fractions, okay? And rarely do you see it as a percent, but I usually use decimals. All right, so here's a new introduction of looking at probability distributions, and we're showing all possible outcomes based on probabilities. So here's your homework, folks, page 374, numbers 1, 2, 4A, 6A, and 8A. If you need any help, come see me. Have a fabulous day. Ciao.